Hey, g'day. Today I'm starting a new project, and this just arrived in the mail recently, so couldn't help myself, had to open it. This is a Nixie tube clock kit. I've had a look at these on eBay for some time now, and the price has come down considerably, and the options are very, very good for doing this sort of thing at the moment. This one comes complete with all of the electronic components that you need. It comes with a real-time clock module which has its own battery power supply and a very, very well made circuit board. The only thing it doesn't have is the 6 Nixie tubes. I purchased those separately, and I think they're coming from the Ukraine. The other thing that I was impressed with in this particular package was the instruction manual. This has all of the setup instructions, and also has a very, very good detailed assembly section as well, and it's written in good English, so I was quite happy with that. There seems to be a lot of support for this particular design. There's a website where you can go with troubleshooting tips and so on. Now, what's made me interested in this is the actual Nixie tubes themselves. The technology has been around since the late 50s and 60s, and it was this wonderful bridge between analog and digital. And if you've ever seen how one of these Nixie tubes is, or how they're constructed, it's pretty impressive. There's a lot of work and a lot of materials, and they just look exotic and very science fiction-y. And that's the sort of thing I'm after. Now, this video is not necessarily about the construction of this module. I don't think I'm going to show that. It's basically just assembling and soldering, and I'm sure others have done that much better than I can. This video is more about the build of the packaging, the case that I want to do for this. So I'm going to have a go at working with some unusual materials. Going to be using some very, very nice Tasmanian myrtle timber. Hopefully I've got a piece the right size. We're also going to be working with acrylic and aluminium, and we're going to be looking at some finishing techniques like anodising. We're going to do some laser cutting, some CNC machining, and just old-fashioned woodworking as well. So I've made a few clocks in my time, and I love clocks. They're functional, but they're decorative as well. And I've also made a steampunk clock as a gift for my brother-in-law, and that turned out really nicely. The only thing I didn't like was that I had to give away a lot of my brass and copper materials, and also a lot of interesting gears and bits and pieces that I had. And I guess the design of this clock is going to be what I call neo steampunk. So it's going to be a little bit more refined rather than the classic steampunk style. So what I'll do, I'll show you on the computer the digital model that I've done, and you can have a look at the general assembly of it before we get stuck in and start making the parts. So let's jump on the pooter and have a look. Okay, well, this is the model. I've used Autodesk Inventor to design this. The whole case is built around 3 pieces of timber. So there's a base that the circuit board will be attached to. There's an intermediate piece, which is just basically decoration, and then the top panel is really just to hold the bezel for the tubes. I'm also going to mount a hygrometer in the front of the case. It's just meant to replicate the idea of an old analog steam pressure gauge or something like that. The top is going to have some cooling vents in it. The clock itself does get warm, but not that hot. But this is going to be, once again, really decorative, but it does serve the purpose of keeping air moving through. Underneath there's going to be 3 cooling holes, so I'll put some sort of gauze over that to stop cockroaches and insects crawling in. And the metal parts are all going to be from aluminium. I'm going to anodise these little decorative rings in gold, and then the caps and the pillars are going to be done in black. and as well as this large bezel which will be cut on the CNC mill. I have prepared some 2D drawings of the parts, and this will allow me to size all my material before, but I'm also going to laser cut each one of these timber panels. Now my laser is not powerful enough to cut right through material at 12 millimeters thick, but what I can do is mark out the profile. If I use a low powered vector cut, it will also mark the centers of all the drilled holes that I need to produce, and it's just an easy way of doing it. So the material that I've got for the timber is Tasmanian myrtle, and I've got just enough to make these 3 timber parts, so I can't afford to screw anything up. These little pillars here are for the neons that separate the banks of digits, and I bought some acrylic tube to make those parts, and the little neon bulbs will just simply be inserted into the end of the acrylic tube. I'm trying to keep the whole thing looking sort of vaguely steampunkish, retro, industrial, so all of the screw heads are going to be either Allen or socket head Allen screws or slot head screws, and in the middle there are 3. I'm just going to make this go away. In the middle there are 3 layers of acrylic, and these are just going to be laser cut, and the edges will be polished, and the idea is that they'll allow the light, the backlight from the actual circuit board to radiate out from those parts. So that's the process. So let's get cranking. Okay, well, as you can see, I've got the Nixie clock working. The instructions were very easy to follow. I didn't have any issues at all except for one component where the orientation wasn't particularly clear, but it was a minor component and it was just a case of trial and error, and I got it right. So the next step is to think about the packaging or the casing that I'm going to build for this, and this is basically the subject of the video. So let's get to it. Alright, I'll just turn that off so it's a bit easier to hear. Those 3 are the last 3 that I did, and as you can see the parts just fall out, which is really good. I did have to tune this machine up quite a lot. It was probably the worst example of Chinese assembly you could imagine. This machine looked like it had been made out of all the bits that were lying around the floor on a Friday afternoon. It's taken a long time to get it to a point where it's reliable and it cuts well. Even the metal casing was corroding. All of this material here has just been sprayed over bare steel, and it was just bubbling up with rust, so I've stripped it all back and finished it with a 2-pack paint, and it's at least looking respectable anyway. So with these acrylic pieces finished now, I have to prepare these edges. Although the laser does a pretty good job of cutting that, and it from a distance looks like it's polished, if you have a really close look there is a texture or a pattern in that surface there, and it's almost dead square to the face of the acrylic. So what I was hoping to get with this was the effect of a Fresnel lens. So when 3 of these are stacked together, there would be a half round profile on each edge, and the light's going to be projected from the inside of this casing, so it will just give a nice effect. So what I'm going to do is to polish that edge and prepare it by putting that half round curve on it. This is one that I've already done. It's probably hard to see, but that is now perfectly polished, and just gives it a nice appearance. So the problem with this is that these things are quite flimsy, and if you're trying to hold this in a vise and file it or sand it or shape it, there's every chance you're going to crack and break this piece of acrylic. So what I've done is I've made a jig which allows me to clamp these to the rigid piece of timber, and I've kept the filler piece that came from inside this so that it's a relatively tight fit, and I'm just going to screw that down with 4 self-tapping screws, and this will just make it more rigid while I do this process. So acrylic is one of those really wonderful materials that gives you a professional looking finish, but the downside is that it is very brittle, and once it's cracked it's broken forever. This is just a Stanley knife blade, and I want to cut half round in it, and I'm just going to use my Dremel to do this. Okay, so that's got the little round on the back of it, and it's got a bit of clearance on the other side. I did start off by draw filing all these edges and following up with sandpaper and steel wool. As you go along with these processes, sometimes you find that some of the steps really aren't necessary, and I did find in the end that just sanding that with some 120 grit sandpaper on a fairly rigid cork sanding block does the same job as the file, and it's a lot quicker. And when you get that sort of dull uniform matte finish on it, you can move on to the next stage, which is scraping. So that's a lot quicker than filing. So I'm just going to clean that off. And with the scraper, we want to be sure that we've got the entire edge contoured, so I'm just putting some felt tip marker around that edge as a sort of a telltale. When all of that's gone, then we know that we've got the correct contour on that edge. I found that the next step was easiest done with a sort of a soft, squishy sanding block and a bit of 240 grit paper. And this is just to remove any final scratch marks. And you can sort of feel and see that texture is uniform now, and then just follow up some steel wool. And what you're looking for is a slightly polished surface with no obvious scratches or nicks or cuts, because the buffing process will not remove those. It's got to be done at this stage. So the next step is to get it on one of these buffing wheels. This is a stitched cotton mop that I keep just for plastics. The other ones that I have for metal have got lots of black oxide in the surface. So I'm just going to use some white polishing compound to charge the surface of the wheel. if you're doing this for the first time, just remember that the top of the wheel rotates toward you, and if you were to place anything in that top quadrant of the wheel, that is from basically from 12 o'clock down to 9 o'clock, in that area there, and you're not gripping it firmly, there's a danger that that work will just simply dig into the wheel. It'll pass the 9 o'clock position and it'll flick it on the floor, and you won't be able to stop it. So the safest option is to use the lower quadrant of the wheel from say 9 o'clock down to 6 o'clock and draw the material up toward you. So as the wheel is rotating, you're just drawing that up towards you. You can go around the corner if you want to, and that's safe, right? You're not going to get into trouble. The only thing you've got to be careful of is that the heat from the friction can burn the surface of that material if you leave it in the one spot for too long. So you do need to keep the material moving. Don't put a lot of pressure on it, and just recharge the surface of the wheel periodically, and you'll be able to tell if you're getting that instant shine on it. It's doing the right job. So what I'm going to do is I'll do that lengthways, so I'll just keep drawing it up that way, do that say 3 or 4 passes, and then a good trick is just simply to turn it to about 45 degrees to the surface of the wheel, and just run that along there 2 or 3 times, and then go back to working along the edge. And that, what it does is it tends to cancel out any of the fine scratch marks that the wheel leaves behind. So let's give it a go. Okay, that's good. That's left that shine on the surface there now. Of course, the okay, well, that's the 6 of those done now, and the profile just breaks up that light pattern so that it sort of gives that interesting texture to it, or geometry to it. And when that's lit from inside, it's going to show that effect up even more. It's sort of ruined a bit at the moment because I've got the paper still on one side of these parts. I have laser cut a registration hole at the corner there, and that will align all 6 of these with the timber parts as well. So it's just going to make the assembly more accurate when I go to do that. So that's just like I bought one, isn't it? Okay, so this is the material that I prepared for the Nixie clock case. This is Tasmanian myrtle. It's a beautiful wood, but it's very difficult to work with. It's got lots of interlocked grain, and the pieces that I had contain a lot of defects as well. You can see this one here. So what I've got to try and do is to mark out my pieces so that I can avoid all of those defects. I've actually printed the drawings full size, and I've just been checking to see where I can place my centre to avoid the sapwood and any of the defects that I can find in the material. So this is the pattern for the bottom of the clock, and this is the stock that I'll be using. So I've got a marked centre there. I'm going to mark this out with the laser cutter engraver. My lathe is only 50 watts, so it's not enough to cut through material that's 12 millimeters thick, but what I can do is vector mark the outline and all of the hole centers. Then I'll bandsaw to shape, drill all the holes, finish it, and we'll go from there. So let's go and have a look at the laser and fire that little baby up. I've just tried that out on a piece of corrugated cardboard, and I think I've got my settings correct. I've set the origin at the exact centre of the part, so all I have to do is align that under the red dot pointer. So I put my stock on the bed of the machine now, and I've got the origin set at the centre. I've got my red dot pointer set up over the exact centre of the part. So let's rock and roll. Let's see how this one goes. like I didn't get it dead center after all, but you know what, doesn't matter. The drill bit that I'm using here is a nominal 25mm Forstner bit. I actually measured this and it's not really 25, it's about 25.2. I've got my centres marked by the laser, so I've just got to be fairly precise in getting those lined up. I'll bore that all the way through. I've got to try and move this scrap piece of chipboard around underneath to make sure I get a clean cut when I go through the other side, because I don't want to chip that out. Okay, so it's good. These holes here, these three, these are just cooling holes, so they're not really critical. So I'm going to swap out for a smaller bit. So this is the top piece, and this slot here is going to be clearance for the Nixie tubes, and the back one's going to be a cooling vent. So I'm going to bore the holes at the extremities, and then I'm just going to cut that out probably with a jigsaw. Okay, that's looking professional, isn't it? So next step on the bandsaw, we're just going to trim up the outside. I'll get as close as I can, probably finish with hand tools. Oh, that was a bit of a train wreck. That blade is way more blunt than I would like to use, so I went around that just trying to steer clear of the lines, basically. That's embarrassing. Anyway, I clear of the line so I can trim that up with hand tools and so on. Hopefully the thinner one will be easier. wasn't much better, but got it done. I've only got the middle one to do, and it's a little bit unusual. I'm going to trim the inside out on the bandsaw, so I'll just grab it to show you. So with this one, I'm going to do the outside profile, of course, and I'm going to cut in from the outside along one of these lines, clean out the inside, and then glue that corner back together again. This part is actually inserted in the stack of parts and will be held in place by the other parts anyway, so there's little danger of that part breaking. So I'm going to trim out, I think I'm going to do the inside first. Now you could just glue that back together again, and probably dimensionally it'd be very, very close. But another way of doing it is just to cut a very thin wedge which can be driven in there and glued on both sides. So from that piece that came out of there, I'm going to cut just a very thin wedge off that, or almost like a veneer, that'll fill that gap. Well, I really regret not changing that bandsaw blade now. It's made this gap sort of very hard to fill. So what I think I'm going to do is to cut this from the other side. I've got to be really careful I don't break the short grain here. I'm going to try and make that gap more uniform just with this little tenon saw. Well, that's better. That gap's more uniform. I cut a very, very thin piece on the table saw to fit in there. I can glue and clamp that and trim it up later. It'll be fine. So I'm just using some PVA. Just find that if you use masking tape, and then as you put it on, just stretch it. And masking tape has that ability to stretch, and it just puts a mild amount of tension on the joint, which is just enough to hold it together till the glue sets. Well, I've done as much as I can with this spoke shave. It's got a flat base, so it doesn't really do these inside curves very well. So I've done as much as I can with that, so I'm going to finish up now with my big bastard. What? Stop sniggering. That's what it's called. See, I told you. Okay, right now one of those oscillating bobbin sanders is looking like a really good investment for this shop. It would make very short work of doing something like this, but I don't know, something to be said for using hand tools. I'm going to call this quits now. This is about as much as I can fit on this first video, so I'll wind it up here. In the next one we're going to finish off the woodwork, have a look at some of the metal parts and the anodising process, I hope. We'll see how we go. But for now, thanks for watching.